Enjoy security, I enjoy hacking things, I enjoy teaching people things, and this course is a research project that I'm doing where I get to teach people how to hack things and get course credit, which is like the best thing you can possibly imagine, pretty much, apart from having to do all this work, which is quite stressful. But it's really fun, so it's all good. So this week we're going to cover web stuff. Last week we covered reverse engineering, and if you weren't here and you don't know it, that's okay. The lecture is online, the lecture slides are online, and this is not a follow-on from last week. So if you didn't understand last week, you can still understand this week, like it's not related at all. So we're going to talk about cross-site scripting, SQL injection, and the basics of web, so how to hack web. Okay, so you can connect to the wireless network and play along. There's the two websites. Basically, don't hack each other, don't hack the router, don't man in the middle connections, don't be a jerk. Like, this is not the time and place. I will happily set up a time and place so you can hack each other, like that's a thing that I can do. But while I'm teaching, it's not fun to ruin other people's learning experiences, so just don't be a jerk, basically. And it's not my router, the websites are running on my computer, like on a virtual machine. So hack the virtual machine, like destroy the virtual machine, but don't destroy my computer if you find a way to hack through the virtual machine, like I use this for uni, so yeah. And don't get me in trouble, because the course won't run again if I get in trouble. You can't even read the bottom. Cool. Alright, so tonight we're going to cover how the internet works, cookies. I'm not actually doing JavaScript, so I haven't edited the slide in a while. Cross-site scripting, which is how you hack the above stuff. Then like backends of websites, which is dynamic content rather than static content. And then databases and SQL injection, which is how you hack those. So, I guess you might be sitting here thinking, why is Sarah talking about web security? Like, what's interesting about it? There's lots of cool reasons to learn it. Basically, one of the reasons, most of the security work you do is web security work. Like if you get a security job, it's probably going to be a web security job. So like, it's useful to know. And if you learn all this stuff, like you'll be ready to do like a pen testing job. So like you can get a beginner, junior pen testing job. So it's pretty useful stuff. It's also very common in CTF competitions like SQLi, so there's always like a web section and you've got to hack some websites. It's also really easy to get started, you don't have to know how to program. I'm talking really fast, try and slow down, and it's how script kiddies get in, so I guess know your enemy. Like script kiddies, if you don't know, are like 12 to 15-year-olds who are like, oh my god, I'm so elite, I'm going to like hack this website by running an automated tool on it and not using their brains and not understanding anything. Yeah, real hackers write tools, I guess, rather than using them. So basically it's pretty interesting and hopefully you'll get a lot out of tonight. So I guess, how does the internet work is a good question. Have any of you done a networking course or know about how networks work or know how the internet works or like could describe that in a nutshell? A few of you, alright, so hopefully you won't be bored yet. So I might just skip this slide and go to the next slide with a picture. I was going to do a demo, but I don't have internet because I spent like 4 hours trying to get the router working with internet and failed miserably. So the internet is a series of tubes, supposedly. Basically, you are a client, you send a request to a web server, and the web server sends a request to the database gets the data, sends it to the server, and sends you a response. Obviously, it's more complicated than that. You've got to find the web server in the first place, and you've got to have the right request format, and the different requests can do different things, different databases do different things, but it's pretty much this. So HTTP, Hypertext Transfer Protocol, is, I guess, the protocol that you use for communicating on the internet. So importantly, it's text-based, which means you can read it, you can look at it and go, this makes sense to me. So like, get/HTTP 1.1 host blah means get the website / at this host. So that will get you the homepage of CSE, basically. It's also stateless, which means the web server doesn't keep track of who you are between requests, which means if you send this message, get blah, and then you send get, like login, and then get like profile, it's not going to know who you are just through HTTP, so it's going to do something more than that. It's quite useful being stateless because it means there's a lot less work for the web server to do. I guess there's a lot less overhead you have to do, and if the server crashes, you don't have to maintain the state and stuff. So it's pretty useful, although hard, I guess, if you want to have state in your server, like you've got to add it yourself. The methods you can use are like get, post, and head. So get is just get some data. Post is like send data to the server. Head will get the top of the page, I think, or the headers, I don't know. And there's others that I haven't seen. So some more examples from Hack to Planet website. get/profile/Sarah, post this. So that means using HTTP 1.1, you might like this website / that, and so it asks this web server to get this website, like this page. Or you can post the login, username equals Sarah and password equals 123. So if my password was indeed 123, this would log me in. And that's saying how long that is, probably not actually 25, but that is how you would send the user data to the server. I guess you can also send data over GET, so you could send like /login username equals blah, password equals blah. But the downside of that is that you can see it in the URL bar, so it's not really as secure, I guess. Not that post is really even secure, but yeah. So post is normally how you send that. Post data. I don't know if the camera can see me when I look at that, that'd be awkward. So then responses, I guess there's a lot of response codes and you don't need to learn them all. 200 means okay, 300 means like moved, I think, 400 means you screwed up, 500 means the server screwed up. Like 500 and something, 400 and something means those things. So like an okay response would look like, here's the server name, here's the date, content type, mention keep alive, and then the content of the website. I just top it off. And an error response is pretty similar, it's got all the same headers, and like 4 or 5 found. Are there any questions so far? Okay, so like I said before, HTTP is stateless, so we need to keep track of things between requests. Like, there's no point having a website where you can not log in. Like, for the Hack the Planet website, if you couldn't log in, you couldn't do anything. Like, how do I keep track of who's who when you submit things? So it's a very important thing to have, and we use cookies to do this, which are small pieces of data that are stored locally on your computer that get sent to the web server on each request. So you might have a cookie that says username equals Sarah, for example, and that means every time you view the web page, it'll send the cookie saying, hey, my username is Sarah to the server. Server knows, oh, you're Sarah, cool, I'll log you in as Sarah, for example. Yeah, they're key value pairs, so they're just like thing equals other thing. Interestingly, this admin equals 1 was actually a Saiska challenge this year, I think it was, where if you changed admin equals 0 to admin equals 1, you were an admin, and that was how you won like the first or second web challenge, maybe the second one. So like cookies can have, that's my next slide I think, can have security implications. Like, yeah, I'll go to my next slide. The slide after this one, whatever. This is an example. So this is not my real session cookie, because otherwise you could become me on this site and be the admin. But I have only changed some of it because I was lazy, so you can probably become admin with this sort of bit. So it's like a response 200OK server stuff, and then set cookie is another header, and then like session equals blah, HTTP only, path equals blah, and then the content link for the site. So making sense so far? Cool. Yeah, so security implications. Like if I have your cookie, I can pretend to be you, or if you have my cookie, you can pretend to be me, which might be more useful because I'm the admin on this site, this hypothetical site, or this real site even. So yeah, if I can steal the admin session cookie and copy it into my browser, then I am suddenly the admin. And this is like, cookies aren't just this, it's really bad security thing, no one uses them. Everyone uses cookies. Like, if I can steal your Google cookies, I can have your Gmail. If I steal your bank cookies, I can hack your bank. Like, they're actually used, and like it's harder to steal Google or bank cookies because of HTTPS and stuff, which we'll get onto, but if you can steal someone's cookies, then you can become them, which is a problem. And also, stupid or insecure cookies can be changed, so admin equals 0 to admin equals 1 from before. Yeah, so they're human readable and can be changed easily is basically the take-home message from this.
Is it the same as a packet?
So packets are data which is sent across the network. So if you imagine, like, this is the cable or this is the computer's A to B, packets are the way that you break up your data and to bite-sized chunks and send it across the network. So this like cookie thing is part of a HTTP session header, like, what's the word I want? Request or response. And so that request or response will be broken up into a number of packets and sent across the network. Alright, so other useful things, there's a referrer which says which site the user came from. So if you go to google.com and click on a link to gmail.com, the referral will be like google.com. So that's just saying, I clicked on a link and now I'm going to another site. And this is where I came from. There's also the user agent, which is just saying your browser name and version. So if you want to check, like, say you've got to have Internet Explorer to use the site or something like that, then you can say user agent must be Internet Explorer and enforce that. Enforce that because it can be easily changed. So yeah, they can be user defined, which means if you rely on this for security, then someone who's security conscious can easily overcome your things. But they can be checked by websites to make sure you're coming from the right place. Like, I might ensure that you only download my images if you've come from my website. So if you've just hot linked, like clicked on a Google link to get to my image rather than gone from my website, I can say, give you like a picture of a cat instead of a picture of my photo that I took or something. Yeah, which is how when you go to websites and it's like hot linking denied, that's how it works. It checks the referrer. Okay, so URL encoding is also important. This is all quite disjointed, but we're going to get to how it all fits together in a minute, so just bear with me. So when you're sending data over HTTP, like the internet, you can't just send certain characters. Like a space is often used to separate things, or a comma might be used to separate things, so you need to encode them, which means a space becomes either a plus or %20. So if you've got a website, like if your username is like Sarah Space, it wouldn't send Sarah Space because that would interpret it as like just being Sarah. So you'd say Sarah %20. So on and so on. Null byte being 00, like it's just the hex, like ASCII value of the character with a % in front. Which is an attack vector because if you put null at the end of the input, you can break things, which is always fun. Like if something's expecting a string, you can either put a null too early, or you can have lots of stuff and then a null, or like it might not be able to handle nulls. So if you're trying to break a website, just try putting null bytes in and see if it breaks. But it's not very big. It's bigger on my screen. Well, I guess it's not actually bigger on my screen because my screen's smaller, but whatever. So HTML encoding. When you have an HTML tag, have any of you guys not seen HTML before? Okay, cool. That's good. I guess I don't know what I'm expecting, but that's good. So you have like tags, obviously, and you can't tell it's bold, but like bold tags, hello makes hello be bold. So if we have script tags alert, that will give us a pop-up box saying whatever we put in there. So if we enter HTML tags and don't escape them, we can do fun things. Like you might have a comment site that says, oh, you can put bold tags in to make your text bold on the comments to have like HTML comments, yay. But if they don't check for script tags, and you can put a script tag in, that's the next slide, you can put a script tag in and you can make things pop up on people's screens, or do other such things, which is cool. So the moral of the story is, if you're making a web app, always sanitize your input. Like instead of having triangle bracket, whatever you call that, turn it into an LT, $LT, semicolon. Because if you display like this, it will appear like that. So unless you want it to be an HTML tag, then escape the tabs. So, how to actually hack web apps. Basically, the protocol you follow is find some sort of vulnerability in the service. So maybe work out what services they're running and try and find vulnerabilities in them. Observe any errors that you get. So maybe it'll say error Apache version 3 or something, and then you can Google like exploits for Apache version 3. You want to find information about like what database they're using, what directories, structures they have, that sort of thing. You can find bugs in their websites by doing things like SQL injection or cross-site scripting, which we're going to cover next. Yep, you can find bugs in websites and exploit them. Another interesting way in, have any of you guys heard of a thing called a virtual host? Few of you. So basically, when you have a web server, often you have one physical computer that hosts a number of servers. So I've got like, I don't know, 20 websites or something, but I don't want to have 20 servers because they're expensive. So I have one server with a bunch of virtual host tags, which says, on this IP address, like if you go to this website, go to this one. If you go to this website, go to this one. Like, load this folder as a web page. So often you might want to hack someone's site, hypothetically, for a CTF. Not for real. So if you're hacking a website for a legitimate reason and you need to, like you can't hack the website, you might be able to go to the virtual host, like find all the websites on that IP and then hack another one on that IP and then get in that way, like get into the server and then use that to get things. Because if someone's got a website that's just one static HTML page, there's no way to hack that because like static HTML is there's no vulnerabilities, it's just HTML. Whereas if you have another, like a PHP website on the same server, that's probably going to have bugs in it which you can exploit. Yeah, so I guess the main thing when you're hacking anything really is it's about thinking about what was the developer thinking when they made this website or web application or program, or like how were they thinking, what did they assume, and then how can you break those assumptions. So maybe they were assuming that your input was going to be 0 to 10 characters. What happens if you put 11 in? Like, that could be a buffer overflow. Or maybe they're assuming that you can only have numbers in your phone number, for example. So what happens if you have strings? Like, you could do SQL injection on the strings, which we'll cover in a minute. Like, the way that security works, basically, is you work out what the people have falsely assumed, and then how you can exploit those assumptions to win, I guess. Okay, so now some pictures. The main way we do this sort of thing with web hacking is that we have a thing called a proxy, which will modify our traffic and then change it. So a proxy is just a thing that sits between you and the outside world. So CSE's got one that's just CSE's proxy, and that'll like cache websites and stuff. But this sort of proxy we can use to modify requests. So the idea is that we'll send a request from the client through the proxy, so the web page will say this is all good, and then the proxy will intercept it, change it, and send it to the server. So if you imagine this wonderful picture, if you've tried to type in test123 as your phone number, the JavaScript on the website might say that's not okay, it's got to just be numbers, not words. So you think, oh, okay, I can't do anything now. But actually, if you have a proxy running and you type in 12345, which is a number, that'll pass the JavaScript thing, and then when it gets to the proxy, you can modify the request and then change the phone number from 12345 to test123 or whatever string you want to inject that wouldn't have passed the JavaScript validation, and then the server will be sent that. And so often people think, oh, you can't type numbers into a text box field, like a tick box field, because it can only be yes or no, or true or false, or 0 or 1. But actually, if you intercept the request, you can make it be anything you want. You can make a phone number field contain any sort of text. You can make any field that has restrictions on the client side, like in your web browser, can actually become anything if you modify it. Like it'll pass on your web page, and then you modify it with a proxy and send it through. So,
yes. Just remove it from the JavaScript chat from the source.
Yes, you could do that as well. But back in the days when we didn't have like developer options in our browsers. So how do I actually do that is a good question. Thank you for asking. So Burp Suite is the one that we use. You can download the free version, configure your browser to use it as a proxy and have a play. So I'll try and do a demo. It might break my screen recording. I don't know if my screen recording is working, so that's probably not the end of the world. I think it was on 4. So this is Burp running on this side. You can see that. You go to the proxy tab, and then you go to your browser settings and change your proxy to be like localhost port, whatever. Am I going to refresh this and find it full of like things that I shouldn't be looking at? This will be interesting. So you can see the request it's sending here is get/http 1.1. That's the host it's requesting. This is the user agent. That's all the other stuff. So I could change my user agent here, for example, or I could change what I'm requesting. I'm also going to go action. I can look on my screen. Do intercept. No, okay. I'll just assume that it'll work. So we can forward that, and then a request will come back. Oh, nobody's hacked it. That's disappointing. So
those the JavaScript checks that you're talking about.
Yeah.
Is that happening on the browser? It's not happening server side?
Yeah. So you can have server side checks where if you submit something to the server, it'll come back and say, I'm not going to accept anything that's not a number for a phone number. Or you could have just client-side ones, which are JavaScript things saying, checking this phone number.
In which case, if it's server-side proxy, wouldn't do much.
Yeah, so if it's server-side, you've got to find another way through. So you can see the request that it's sending, and if there were anything interesting on here, we could intercept it. Have you guys added things? Like test? Oh yeah, I've got to flood it. Yeah, I don't know if these were here or if you guys put them there, but so you can see the requests coming through and you can intercept them and do things. We can do more interesting things in a minute though when we get up to that part. So some more useful things to note before we actually get on to hacking for real, which we're almost there. This is pretty much hacking. Robots.txt, have any of you guys heard of that? A few of you? Basically, it's a thing that you put on a website to say, web spiders aren't allowed to look in this directory. So if you have like a private folder or an admin panel or something like that, you might put disallow private, which means Google's like indexing bots can't index this on Google. But human can come along and look at robots.txt and see, you've disallowed private, I'm going to look at private and see what's in there. So this is one way that you can find out interesting things about a website. You can also manipulate URLs. So if you've got like view user.php !ID equals 1234, maybe you can go to edit user. Just because it's not linked to doesn't mean the page doesn't exist. And maybe you can edit the user without being an admin. Or maybe you can change the user ID from your user ID to someone else's to edit their things. Yep.
Is there a way of having a robots.txt without making it visible to people who commit that?
Because if you can't see it, then how do you see it as a bot? If Google can see it, then you can see it. I guess you could do a thing which was like checking in the server what someone's user agent was, and then if it was a robot one, you could show them it, but it's...
And you just fake that.
Yeah, you can fake that as well, but it's a lot of effort to go to, and the hackers can still get into it.
So if you're a robot and you're not on the allowed list anyway, then you go into the folder and you call it, so that's not what you want.
Yeah, exactly. Another cool thing is directory traversal. So if you've got like a path, so site content path with upload/image, you might want to try like path equals // which in Linux, if you don't know, goes up a directory. So go up a directory, go up a directory, go up a directory, /etc/password. Are there any questions about this before we go on, apart from the interesting thing? Yep.
So about robots,
yeah.
So the main purpose of that is just for callers. We don't call this data. But is there any way that you can actually do disallow? Because I know about HT access.
Yeah.
Is that the only way we can technically block? Say that's on Apache servers, you can block that.
Yeah. So something like HT access, it's a thing that you can put on a web server, which will block. It requires authentication. So you can either block all people, or you can say you need to log in with username and password to log in to this thing. So that's if you want to protect something, you either do that or you have a dynamic site with a login and an admin login or whatever. You'll find all those silly blog posts and stuff have an admin login, and you can log in as the admin if you are the admin, or if you know the admin's password, and you can do stuff.
Is that that HT access thing? Is that also where you set privileges for different PHP pages? Or is that there's there's 3 numbers when you set PHP.
Oh no, that's not HT access. That's file system permissions.
Okay.
So that's
and so you can't restrict access to folders and stuff with that.
You could chmod things if the web server user can see them, the user that Apache is running as or that Nginx is running as can see the files, then they'll be on the website, and otherwise they won't be. Okay. There's one Unix user that runs, or Windows user if you have a Windows web server, that will run on your server. Hello, fashionably late. That will run, and if that can access the files, you can see them. Otherwise, it can't. It's the binary thing. From before, we had cross-site scripting. So basically, this is where my notes get kind of bad. If you have unescaped HTML on sites, like I said, you can run scripts from other places. Hence why it's called cross-site scripting. I guess it's good for a lot of things. You can steal someone's cookies, which, as I said before, if you have someone's cookies, you can be them, so that's pretty cool. All those Facebook spammy worm things where you click on a thing and it's posts to all your friends and invites all your friends to stuff automatically. That kind of thing is done with cross-site scripting. Someone's 9447 project, Comp 9447 is a security course where you do a fun project, or did do a fun project, but I've changed it now. Someone's project was actually making a botnet, so a bunch of computers, whenever they viewed the XSS thing, they would all become part of the botnet, and then they could execute commands remotely on all these computers as long as they had the website open and it looked like their other website. So that was really cool. It made them all play audio or something. It was very exciting. And you can do a lot of other stuff as well. So there's 2 types of cross-site scripting. The first one is reflected, which is non-permanent. So if you imagine we've got website, passing q equals kittens, like searching for kittens, and it shows us kittens. But if the website doesn't escape script tags, then if we go to the URL kittens, script tag, malicious site, authentication stealer, if I send you this link and get you to click on this, then it will steal your authentication, run my script, and presumably the script will log in on my site so that I can view it later on. So, if I send you this link and you're logged in, I can steal your login, and if it's, let's say it's like an e-commerce site, and it lets you view things to buy and buy things, so it might have credit cards stored on the site, and maybe you can view your credit card and change your credit card. So if I send you this link being like, look, you can buy kittens online, aren't they so cute? And then you click on this link, I can steal your cookies, I can log in as you, I can look at your credit card details, I can steal your credit card, I can rack up $1 million of pizza charges to buy you guys your pizza next week. That's one of the reasons why websites don't show your full credit card number, they only show your last 4 digits. But that's the sort of thing you can do with cross-site scripting. So that's called reflected cross-site scripting, which means it's non-permanent, it's just in the URL itself. More fun things I'll show you in a minute. Yeah?
Page with the script in it.
So you'd need the script to be somewhere. Either you could have the script be, if it's, you can do a script tag, script and then JavaScript and then close script tag, but that's probably going to be too long for a URL, usually, unless it was just alert or something. So.
Is that actually, your browsers allow that in URL?
Yes. Yes.
On the file, you can also run it in the debugging console.
Yes. You can also trick someone into running stuff in the development console where you can run JavaScript scripts. So I think if you go to facebook.com and then view the development console, it gives you this warning saying, if you were tricked into coming here, this will not get you free likes on Facebook, this will not get you friends, this is going to hack your account, don't paste anything in here, which I thought was pretty cute. I'll show you guys that when I've got internet again. So the other type of cross-site scripting is persistent, which is permanent, as opposed to temporary. So if you imagine on our website, maybe a blog site, we've got comment boxes that don't escape script tags. So you post a comment that says, hello world, script source auth stealer. If you view this blog post and look at the comment, then it will run the script because it's embedded in the comment, so it'll just run when your browser loads it. Is that my bag beeping? Anyway, it'll run the script and steal your cookies or whatever it's going to steal. Question mark, profit, pretty much. You can embed scripts in comments on blogs or that sort of thing in places that don't escape script tags or escape things sufficiently. So Facebook would, my website would. What'd you say?
Yeah, I was just going to say that the other website.
Yes, my website does now. I misread the documentation and thought that safe meant make it safe, but actually safe means don't escape it. And E means escape, so that was awkward. Don't follow tutorials, read the documentation, is the moral of that story. But it's fixed now, so you can no longer XSS each other on my site, thankfully. Are there any questions about reflected or persistent? Does this happen a lot?
Yeah, cross that kind of stuff.
I think
comments.
75% of all web hacking is XSS, so it's pretty common. What did you say?
Only 75?
Well, there's other ways you can hack, like SQL injection. The big companies get this all the time, basically. And hopefully they're secure, but if you work somewhere what's a big company? Facebook, I guess, it's not just Facebook, it's Facebook Messenger and Facebook comments and Facebook likes, and so there's all these sub little parts. And it only takes one bug on one sub part of the site that will break everything. It's really interesting to read. They have bug bounties, places like Facebook and Google and that sort of thing, where if you hack something, they will give you money, if you tell them, rather than hacking it and exploiting it. The idea being that rather than selling it to the Russian government or whatever, and getting rich off them being able to hack people's Facebooks, you can give it to Facebook and they'll pay you money to, be a good guy rather than being a bad guy. And often people will do write-ups of this sort of thing, so they'll say, I hacked Facebook, they'll fix it now, but this is what I did, read blog post, and it's just, the things they do are amazing. There was a Google one, and it was this crazy, error page for some obscure service that was closed down several years ago, and it still happened to exist for the error page, and they did some crazy thing and they hacked it. Yeah, so it's cool. Security is cool. It would capture your cookies like this. Username equals Sarah, pretend cookie I have. So you can see from my IP address, where is the IP address? Over there, yeah. So UNSW IP address, 3 seconds ago, when I took the screenshot, it captured someone went to this, and the cookie was username equals Sarah. So if you're actually on this, it'd be like, you know, cookie equals session ID equals for the admin session ID or whatever. But it's a very useful tool. Cool, so that is all the cross-site scripting stuff. Are there any questions about cross-site scripting? Casually get a drink while you guys think about questions. What did you say? Ah, well, I can reset them. After the lecture, I'll reset them. So, the second part of this talk, or the third part, I guess, first being basics, second being cross-site scripting, is like back-end stuff on SQL injection. So, you probably have noticed that most websites these days are dynamic, so they're not just like an HTML page. There's some websites still from the 90s that have just static HTML, but like Facebook is dynamic, Google is dynamic, CSE's website is dynamic because you can log in and do stuff. My Hack the Planet website is dynamic, Open Learning, like every website is dynamic. So what dynamic means is you've got some script in the background that runs, that generates the content for the users. So it could be as simple as like having a web page with like PHP echo usernames to be like hello echo username, how are you? To be like hello Sarah, how are you? Or it could be as complex as Facebook or Open Learning or whatever. If you have a website written in PHP, you get excited because PHP has negative security, like that's how bad it is. If you have a website written in Python or something, then that's probably more secure. Like PHP has made so many bad decisions that they've made their security so bad that it's like you can almost hack them by looking at them. It's quite bad.
Then why is it so popular?
Because it's very easy to write. Whereas with languages like, I guess, I don't know Ruby very much, people can correct me on this, but I think the more modern languages for web scripting, they've designed with security in mind. So they've sort of thought, how can I make this language more secure, and built some security features into the language or into the web frameworks. So like with the Flask stuff that I made the Hack the Planet website in, I can just import like a password hashing library, and I can import like a login library, and it'll do login securely for me.
It's all about making it really hard to make mistakes.
Yeah, it's about making it hard for developers to make mistakes, because developers are lazy. You guys might have the best intentions in the world, but you will have deadlines. It will be like 3 in the morning, the launch is 8 AM tomorrow, you've got to get this website finished, you're going to be like, screw all my best practices, screw what I learned on 1917, like, screw coding style, I'm just going to write terrible code, because it needs to get done, and it's how the world works. There's never enough time, and projects always get out of scope, like, things explode. So it's just, the reality is that developers will make mistakes. And I mean, somewhere like Google, where they have really good standards for like, you know, you've got to have people look at your code, you've got to do code reviews and stuff like that, there's going to be less mistakes, but even so, it's still possible, like, developers could still make mistakes. It's not foolproof. So it's about designing languages with the developers in mind, thinking, how can I make it hard for them to make mistakes that will cause security problems, if that makes sense. So databases, from our like second slide we had, you know, we have the server, the computer connects to the server, connects to the database. Databases are things that store data. Dynamic content is stored? That's not true at all. What was I thinking when I made these slides? It was like 11 o'clock at night. Don't do that. So databases store content, which is then generated into dynamic content. So like the database for the Hack the Planet site has a table called users, which has your username, your email address, your ZID, your password hashed, like all that sort of stuff, your points or whatever. A database stores information, often like columns, so I have a chalkboard. Forgot about that. Like this might be the users table, so you might have like ID. Which way around did they go? If they go this way, right? Maybe ID, username, and age, because it's going to fit. So like ID 1, username Sarah, age, question mark. ID 2, username Bob, age 18. Like, that's what a database is going to look like. So you have content in the database, a fixed schema, they're called, for how the database is laid out, and then SQL in like a MySQL database, most databases actually, is the language you use to talk to them. So I think the next slide is an example. But it would be like select star from users where ID equals 1, and that would give you this row. That'll be easier with the words, yes. Oh, we're username equals test, okay. So we'll be test user with age 15. So, yeah, a SQL query, like all you need to remember, you don't have to remember much. You've got select whatever you want, select ID or star for everything, from table names, users or whatever, where thing equals thing. So username equals test, for example. The problem is, if the website has, you know, user.php question username equals test, and test is passed straight into the database, can you guys see what might be wrong with this? Like, if you can pass in anything you want right into the database.
You can put queries into the database and pull kind of stuff out.
Yeah, we can change this query, right? We can put some SQL in. So we can make our username, can't write on this thing. Our username can be test quote to close off this test thing, and then some SQL. This is called SQL injection. If I haven't said that, I have basically SQL injection. There we go. So for example, if we said username equals test or 1 equals 1 dash dash is like a comment to end the line and then a speech mark, the speech mark will be put in. So if we went to this URL, this will return a result from users where either the username is test or 1 is equal to 1. Now since 1 is always going to be equal to 1, I hope, this will return all of the users table. So you can do this sort of thing for if you're logging in, say you're logging in as the admin, and the admin requires a password. You can say, you know, password equals password quote or 1 equals 1, and then it'll say, you know, select staff from users where username equals admin and password equals password quote or 1 equals 1. And so it'll be like either the password is right or 1 is equal to 1. If the password is right, then it's right, and if the password is wrong, then 1 is equal to 1, so it'll log you in as the admin. It's a very easy way to cheat your way into a system. Are there any questions about this? Does this kind of blowing your minds with how insecure the internet is? I should have prepared. There's a Syska demo which one of my friends demoed. I had some family visiting from New Zealand. I'm from New Zealand if you didn't know. And family were visiting and they saw my friend's live demo of the Syska challenge and they were like, is it that easy to hack the internet? Oh my god! Like, it's pretty insecure, the internet in general.
So the spaces won't get converted to escape?
They'll get turned into %20, yeah. So you'd have to...
Because well, it's part of... You can have spaces in queries.
Like you can't have spaces in Earl, but you'll have %20s in the Earl, but the web server will remove the %20s before it sends it to the application.
Yeah, so if it's a %20 in the URL, it'll get turned into a space by the web server when it sends it to the database, depressingly enough. So, how do you actually find SQL injections? Like, try and break it, basically. Try and screw up the SQL. In a perfect world, where hacking is easy and amazing, you get an error saying, like, incorrect SQL syntax where, you know, you had a quote in the wrong place. This is what your SQL line was. And then you can see the whole SQL line they were trying to do, and you can go, I just need to change my quote around, and it'll be really simple. So, in an also good world, you just get an error being like, error invalid username, or error 505, 500, yeah, 500 error, which means server broken, basically. Yeah, so you can try inserting 1 quote, and then inserting 2 quotes, and then seeing if it changes. So seeing if you've managed to close off the SQL expression, and then seeing if you get, like, you know, invalid username for one, and invalid password for the other one, or that sort of thing. Seeing what the query might look like underneath. Another thing you can do is create equivalent strings. So say we're logged in, like, to the profile page, and it's saying, you know, user ID equals 5. If you do user ID equals 2 plus 3, and you get the output for 5, then that's saying that it's actually taking in that 5 you've passed in and passing it straight to the database and evaluating it like as maths. So if you got the output for 2 when you did 2 plus 3, that would be good because it means that it's not actually passing this in and evaluating it. But if you got the output for 5, then that means that it's SQL injectable. Like you can take this and then make it be, you know, ID equals 2 quote or 1 equals 1 or whatever.
You actually use like 6 minus 1 because the pass will be a turn into a space by the browser sometimes.
Okay, thank you, Neil. It should be 6 minus 1. That's probably why it didn't work on SciSco. So that's all my slides, but it's your turn to try. So it's after 7, so we can go to the lab. I vote we go to the basement labs. I'll set up the router again. You can go on your laptops if you have them. There'll be computers if you don't have them. If you don't have a laptop, there's also, or if you're finished with these, there's also online challenges you can do called Natas or however you say that. And then you can submit that for points on the hackathon site, which is super good. Are there any questions about this before we go on?
Find the directory.
Yeah, I'll get there.
What about JavaScript injections?
I was going to talk about those and I didn't, but I'll save those for 2 weeks from now when we do web advanced stuff.
Okay.